From the 22 News Plus studio, this is 22 News in Focus with Patrick Berry.
Good morning, everyone, and welcome to this edition of InFocus. I'm your host, Patrick Berry. We're here in the 22 News Plus studios talking about amazing research that happens right in our backyard. I'm very happy and excited today to be joined by Peter Reinhart. He is the director of the Institute for Applied Life Sciences at UMass. Like you, I have no idea what any of that means, which is why Peter is here. So, Peter, give me the umbrella. What is life sciences?
Well, life sciences, answering that question is slightly different than what is the Institute for Applied Life Sciences.
Okay, so, all right. So let's start with your specialty, the Institute.
The Institute for Applied Life Sciences is a very broad institute that has a very specific focus on campus that's a little unusual for academic environments. What we try to do at the Institute is find those laboratories that have interesting research going on that is far enough developed that it could actually start to have a positive impact on society.
Okay, so
in other words, it's moving beyond the research lab and possibly something that people might want to take advantage of.
Okay, so, God, I have so many questions. So what do you work on a daily basis? Or I guess let me rephrase the question. What have you worked on historically that the general public is experiencing today that we probably don't think about how much research goes into it?
So the two or three areas I've worked on have mostly been disease focused. The biggest of those is Alzheimer's disease. So I've spent many years thinking about what goes wrong in an Alzheimer's patient, what could we possibly do to improve the quality of life, both for the patient and for the caregivers. So that's one major disease. My own background is neurophysiology, so I tend to look at those areas that affect the brain and diseases of the brain. And the three big ones are Alzheimer's, Parkinson's disease, and Huntington's disease.
And all of that research is taking place right here in Amherst.
All of that and a lot more is going on in Amherst. We have over 1,200 research groups, and each individual research group has between 1 and 3 research directions. So
in Amherst?
In Amherst. So if this program were to last 3 months continuous, we still probably would not be through all of the research that goes on there.
So why is this so important to have right here in Western Massachusetts? What is it? Why not UMass Boston? Why not, Bentley, Harvard? Why UMass Amherst?
So there are a lot of answers for that. This is the flagship campus of the UMass system. This is where most of our students are educated. So this is the campus that has by far the largest student number. So this is also the place where we have the largest number of faculty, and part of the value that the students get from being trained in Amherst is the fact that they are research active faculty that are attacking problems that are with us today. What are the unmet needs? What are the things that society needs? Everything from clean water to cheaper energy to wearable devices that monitor your health in between the few times you get to see a doctor, possibly even contributing to a reduction of healthcare costs, because instead of needing a lot of face-to-face time, if you had a wearable device that can track 1,000 signals in your body and start throwing up flags when something goes wrong, that would be much more effective and would allow for a much earlier intervention than waiting to see your doc once or twice a year, and maybe the symptom might be picked up and maybe not.
So, I have a smartwatch on. A lot of people now have smartwatches. More than just getting a text message or telling me the time, and these are devices that can be used to make our health better.
Yes, in a somewhat roundabout way. The device itself, at least as they exist today, are predominantly measuring devices. They're not intervention devices. So we don't yet have devices that can treat Alzheimer's disease.
Right.
But if we could have a device that allows us to identify who's at risk for Alzheimer's disease 10 years before you forget where you live and what your name is. Imagine the intervention opportunities that opens up, instead of now having a disease that's been with you for 10 years and now you're trying to treat it.
Right.
You catch something at the beginning, you have a much higher chance of having a meaningful intervention that buys you what patients really want, which is increased quality of life for a longer period of time.
So, and that is just one of
That's
many,
just
many.
one of many, many, many. Yes.
So the facility in Amherst what's the state of it today, and what's the future looking like?
So it's a very sophisticated facility. The building was largely funded by the UMass Life Sciences Center about 10 years ago. That had a very significant influx of capital that allowed us to build a building, fit it out, bring really cutting-edge equipment into it, and hire faculty into a very specific domain. Not in terms of whether they're biochemists or nurses or engineers, but their interest from the get-go is to develop things that could be put out into the public for the public's good, like a wearable device that might measure your gait or your cognitive abilities, and then throw up a flag and say, your memory isn't as good as it was last month. Maybe it's time to see a doc.
I'm floored. But again, that's just one of the many things that you folks
One of the many,
folks are
many
working on.
things, yes.
The investment in research, it made the news late last year that the federal government was cutting back research for a lot of universities.
Yes.
Was UMass affected by that?
Yes, I think UMass, along with many, many other universities, was affected. There's a slowdown in the grant review cycle. There's a decrease in the number of grants being funded. There's a decrease in the total dollars flowing onto all campuses, including UMass. The net impact of which, as you might expect, is now we can hire fewer people, fewer students to work on these pressing problems, less money to buy equipment, which means the rate of progress in advancing our knowledge about what goes wrong in the body as one of the many things, or how we might want to clean up our environment as one of the other themes that we work on, that is all slowed down. So as that funding slows down, our ability to work in that space slows down. It also has a global impact in that the U.S. becomes less competitive. Other countries are not slowing down.
Right.
So now this primary position that the U.S. has always had and enjoyed and frankly almost taken for granted is now truly at risk.
We are up on our first commercial break. We've got plenty more to talk about, so stay with us. We're back in just a moment.
This is 22 News in Focus with Patrick Berry. This is 22 News in Focus with Patrick Berry.
Welcome back, everyone, to this edition of InFocus. We're having the discussion with Peter Reinhart, who's across the desk from me. It's the Institute for Applied Life Sciences that is on the campus of UMass. The research work that they do within that facility covers every aspect of our lives, clean air to, as you talked about, bettering our health and better monitoring our health. You've gotten a number of grants. You get grants all the time and are awarded money all the time. But I need to read this one because I want to make sure I'm pronouncing it correctly. The Mass Spectrometry Core Facility. Did I get that right?
You did.
Wow.
Very
Okay.
good.
All right. Tell me what that does and what the money will go towards.
Okay. So this is so when we say core facility, we're talking about a physical space. Think a room maybe 3 times as big as this that has between 1 and 10 instruments in it.
Okay.
That has an expert person running the facility. So that's just what defines what we mean by core facility. So it's a space that houses equipment, that has an expert running the equipment. And that equipment we make available to everyone. And I truly mean everyone, not just people on our campus. If you're a startup company that happens to need that piece of instrument, we make it available to you. If you're an operation, even in Boston or in Pittsfield, we make it available to you.
So this isn't just equipment and space for you as UMass employees and the students, whether there's undergrad, grad, or what a PhD. This is you make this available to anyone who needs to use this, because I have to imagine that most people can't afford to do this.
Most people can't afford to do it. And even if you're a smallish company, if you're anyone other than a huge company, it's pretty difficult to afford a $2 million instrument that you might only need 3 hours a week. So you just don't have the wherewithal to buy it. But we buy the instrument, we put it into a facility, we have an expert staff member that advises on and teaches on how to use it, and we make it available to everyone.
So who are some of the people using the equipment and how are we as general consumers and part of the population, how do we see the end results, the benefits of the use of that equipment?
Yeah, there are two questions. There are a lot of users, everyone from other universities, other campuses. That's the sort of university side use that's more on the research side. And on the application side, we have a lot of companies that we've developed relationships with. And the state actually had a very nice state voucher program that unfortunately stopped last year, but they actually gave companies a subsidy to use our core facility. So if a small company, this is for small companies only, a small company comes to us and wants to use our equipment, it might be a $3,000 job that they're signing up for. The state used to pay for about half of that.
Oh, wow.
And so that was a great deal that made our small companies more competitive. But again, it's very easy. You just pick up the phone or send us an email and say, hey, I have an interest in using our mass spec equipment. We have 9 mass specs in that one facility. We can do everything from genomics to proteomics to metabolomics. I can go into what that all means, but it basically means we can analyze lots and lots of samples and tell you exactly what is in that sample, which is very important for lots of research and development applications.
It sounds as if this facility is the uses and the benefits are really unrestricted. I mean, I think of just the short time that we're having this conversation, my brain is firing on all cylinders, thinking about all the different things that we experience in our regular lives that the research really comes to help us.
Yeah, absolutely. And you sort of ask how many different uses can be put to. As you say,
countless.
It's as many as the imagination drives. And for some of them, we may not even know exactly what it's used for.
We don't know what we don't know.
Well, what I'm saying is, we make the equipment available and we ask for a sort of an overarching research plan, like what is going to be done on the equipment. But sometimes a company may want to hold something back a little bit so they're not putting things into the public domain. And that's okay too. But basically, it's a wildly open set of equipment facilities, and we're talking about one core facility.
Right.
We have about 30 of them. We have about 800 pieces of equipment that are sitting in those 30 core facilities. So there is not much that you might want to do that can't be done in one of our core facilities. But you're asking about the specific use case of a mass spec facility. What it can do is take very, very small samples, right down to single cell samples, say the scrapings of the inside of your cheek, and now do a complete analysis of almost every single molecule that's in there. And different mass specs do different things very well. For instance, you might want to know what every metabolite in your cheek scraping is. That's every sort of food-related small molecule that might be there. That set of molecules might hide a biomarker for the onset of a particular disease. Or it might signal that there is something not right about your diet or your state of health. But you can get that from a tiny, tiny little sample, non-invasively gotten. You put it into one of these machines, and it tells you everything that's in it.
So backing up, it sounds like your organization is a very open-minded, free-thinking, where you just I look at this show here. I go, what does Patrick Berry want to learn about today? It sounds like you guys are doing the same thing in a certain way. It's okay, the scraping of the inside of your mouth. Somebody at some point in time said, I wonder what this will do.
Yeah.
And then you take that and you just follow a research path for it.
Well, exactly. And like I said, often one of the applications of that research path is to come up with biomarkers. And biomarkers is a fancy way of saying, can we find a signal coming from your body that tells us that something isn't quite right? That's
what it boils down.
That's what it boils down to. Okay. And there's a second use of biomarker that says, okay, let's just say we found something isn't quite right, and now we treat you with a drug or a molecule or a pill or a physical treatment, and now we want to know, are you getting better?
Okay.
The biomarker will tell you. If you have a biomarker that decreases, and now we say, hey, there's something not quite right with you, now we put you on a treatment and the biomarker reverses, now we know not only have we identified there's something not quite right with you, but the treatment we've put you on is actually effective. And if you think about things like depression, for instance.
Conversely, not effective.
Exactly. So there might be 6 treatment options, and each of them only treats 10 or 12% of the afflicted population. You could go through one by one and then put yourself on them for 3 or 6 months at a time, or you could even just take some cells from your body, put them into a dish, provide 6 treatments, measure the biomarker, and now you know
You have your
from the
result.
get-go what treatment is going to be effective for you in particular.
We are up on our second commercial break. Stay with us. Plenty more to talk about. We're back in just a moment.
This is 22 News in Focus with Patrick Berry. This is 22 News in Focus with Patrick Berry.
Hello again, everyone. Welcome back to the 22 News Plus studios. I'm your host, Patrick Berry, here at InFocus. Sitting across the desk from me today is Peter Reinhart. He is the founding director of the Institute for Applied Life Sciences up at UMass Amherst. Peter, thank you so very much for joining me today.
Happy to be here.
Again, like I always do, I've got so many questions, and we've only got so little time. And you joked in the commercial break there, like you barely scratched the surface, as they say. Let's get back to the instruments that are used. When I think of scientific instruments, I think of the most basic things like a microscope and that kind of, but these are way more technically advanced than your average high school microscope.
Yes, they are.
Tell me.
So, for instance, we recently received an award to buy 2 new instruments for our core facilities from the UMass Life Sciences Center. We just talked about one of them, a new mass spec instrument that can do a very sophisticated work with incredible sensitivity and incredible speed. That's one instrument. The other instrument is completely different. It's a printer. But this printer, instead of printing words on paper, this printer actually builds devices.
What kind of devices does it build?
It builds, for instance, one of the items that's on the printer right now as we speak is to build a new type of injection device. It actually builds nanometer-sized needles that have tiny, tiny little holes on the side of the needle that can be used to inject compounds into your body. But instead of being a long metal needle that it gets jabbed into you, this is a needle that is so small that you don't even feel. It's actually an array of needles, 3D printed needles on an array, and you can think of them as being needles that cause absolutely no pain because they only penetrate 6 or 7 microns.
Let me interrupt you there because I hate getting shots.
Yeah.
Absolutely hate. And
So do I.
I'm not alone. So just that change in technology that's happening up at UMass could eventually benefit me, the guy who hates getting shots, if I need the flu shot or whatever it might be.
Absolutely.
My fear, my sweaty palms, my sweating, my fear of going to get that shot, almost non-existent.
Exactly. Brand new technology, nanoscale sized needles.
Okay, sign me up. When can I get it?
Well, I mean, it's in the testing phase now. This would become a new, what's called a medical device. It needs to go through the regulatory process. The regulatory process is a government agency that makes sure that whatever is being developed is safe and doesn't harm anyone. And you need to have lots of data to show all that. So it usually takes a few years to get through that process. But once you're clear of that process, you could now buy those nanoneedles, or your doc could be using them. And keep in mind, it isn't just for people like you and me. Think about kids.
Right.
They have
That's where my fear of needles came from when I was a kid.
Absolutely. Think about babies.
Right.
So now having a non-invasive, safe way to be able to treat those populations would revolutionize how we think about giving drugs to people.
So let's go back in time. Was it somebody in your facility like you and I who hates needles who said there's got to be a better way to do this? Is that how it starts? It
does. It's actually a new faculty member in our engineering group that brought this in as a project. She came to us with this idea. She was actually the co-PI on the grant the grant application that we wrote, and that's her work that's now ongoing.
So as we're having this conversation, the research side of it is one thing.
Yes.
And you think about how the human population, not necessarily Western Mass, United States, the human population benefits from the things being done on the UMass campus. There's a huge economic benefit to this too, because, and again, to your example, you're creating these small businesses that then hire employees and they're making revenue. So there's a huge economic potential for what's taking place.
It is. And again, during the break, we talked a little bit about this all takes time. You don't develop this in 3 or 6 months. But But some of these companies have, and some of these ideas have been going for 7 or 8 years. And so now they are getting closer to the point where they could have impact. There's a company that came out of UMass that's developing a new way of printing and developing optics. Instead of large pieces of glass, you actually build microarrays of much smaller lenses. Very revolutionary way of doing it. They're actually now building up their facilities both in Amherst and out in Pittsfield at the Berkshire Innovation Center.
Okay.
So now here you have the beginnings of some of this translation of the research that started in a research lab, now turning into companies, turning into employees, turning into physical space being rented in Western Massachusetts.
And it all comes down to funding. Because if you're not getting the money, none of all this comes to a screeching halt.
Absolutely, comes down to funding. It also comes down to infrastructure. Can we provide spaces for these companies to start up in? Can towns do they have enough wherewithal to allow a company like this to start?
Right.
Often townships are used to plumbing firms and things they know and understand. This is very different. This is really high tech. But clearly, Boston, Cambridge, the Seaport District are doing this by the hundreds.
Right.
We could be doing it in Western Mass as well.
We have the space.
We have the space.
We have the brain power.
It actually costs a lot less money to do it in Western Mass than it does in Cambridge or the Seaport District.
Absolutely.
And we have the brain power. We have the people being trained. So we have all of the ingredients we need to actually create a very viable economic development infrastructure in Western Mass that can really have impact.
We have only done the very small tip of the iceberg, Peter, but I can't thank you enough for giving me your time. I would love to have you back if you'd be willing to come back.
Very happy to come back and maybe go the next couple of millimeters into the iceberg.
Peter, thank you so very much. Wonderful meeting you.
Appreciate having me here. Thanks a lot.
This is 22 News in Focus with Patrick Berry.